Hi there! Have you ever seen this equation and thought to yourself, what? Maybe you're thinking that right now. Well, today we're going to look at this equation, known as the most beautiful equation in math, Euler's identity, e to the I pi plus 1 equals 0, along with our good friend Moiler. This equation is extremely daunting as it is, and it's hard to wrap our heads around the idea of raising a number to the imaginary power. What does that even mean? Let's start with defining each of these terms. E is the value that this expression approaches as n increases. Another way to express E is as the sum of this infinite series. E is an irrational number and the base of the natural logarithm. I is the square root of -1. Huh? The square root of a negative number? That doesn't make sense. Well, it isn't possible in the realm of real numbers, which is why mathematicians have created a separate category of numbers called imaginary numbers, for numbers that deal with the square roots of negative numbers. Pi is another irrational number and the ratio of a circle's circumference to its diameter, and 1 is, well, 1. This formula links together four completely different numbers to result in a value as simple as 0. But why? How? So there's this guy named Leonard Euler who was playing with the famous Taylor series one day in the 1700s. A Taylor series is an expansion of some function into an infinite sum of terms, where each term has a larger exponent like x squared, x cubed, etc. We can use the Taylor series to approximate graphs like the sine wave, cosine wave, and graphing e to the x. Here, let me show you. As you can see, the approximations start out poorly, but as we study more and more terms, the more accurately the graph mimics the original function. This is the sine wave, this is the cosine wave, and this is the graph of e to the x. Anyways, Euler was playing around with the Taylor series and thought to himself, what if I put an I in there to be e to the I times x? So he put I into this equation and remembered that I squared simplifies to -1, so he simplified that. And then he grouped together all of the I terms at the end, and miraculously he realized that the two groups were actually the Taylor series for cosines and sines. He thus concluded that e to the ix equals the cosine of x plus I times the sine of x. And that's the story of Euler's formula, but we aren't done yet. So let's put in some values for x. And then let's graph them. But instead of graphing them normally on the coordinate plane, we have to use the complex plane to accurately describe the complex numbers. So what do you notice about the graph? Yup, putting Euler's formula on the graph produces a circle. And finally, if we plot the graph e to the I pi, we see how e to the I pi equals -1. We finally found out why e to the I pi plus 1 equals 0. So I hope this video was useful, and I hope you understood how this equation works. I'll end this video with the final note to only accept things people say if you can thoroughly understand it yourself. Ask yourself questions and have a mind for your own. Thanks for watching!